Hello. Today we're going to look at some applied critical point problems using optimization. One of the classic optimization problems is if we have a garden within a rectangular area that is going to be surrounded by fence, and we want to find the largest possible area with only a certain amount of fence. So the problem that we're going to work on is going to be, what is the largest possible area of the garden if only 100 running feet of fence is available? So first things first with most of these problems is that we're going to draw ourselves a picture. So I'll draw myself my rectangular garden. And I don't know the exact dimensions because that's what we're trying to find out. So I'm just going to label my sides Y and X. Alright, since we're trying to find the area, it'd be helpful to have the equation for area. Since we're dealing with a rectangle, I know that area is going to equal x times y. Alright, and then from the other part of my problem, I know that I only have 100 feet of fence to work with. So that means that the perimeter of my rectangle is going to have to be 100 feet. So I know that I can write that as 100 is going to equal the perimeter, which is going to be 2x plus 2y. Now what I'm trying to find is the greatest possible area, meaning that this is the main equation I want to work with. But it has two variables with x and y. So what I want to do is use a substitution from this equation, putting it into here, that will bring us down to one variable. So we can just pick either x or y, it doesn't really matter which one. So let's get x by itself. So we'll subtract 2y from both sides. I have 100 minus 2y equals 2x. We'll divide both sides by 2, divide by 2, divide by 2, and we'll get 50 minus y equals x. Alright, now that we have that equation for x, we can plug it into our area equation. We'll have area equals, instead of x, I'm going to write 50 minus y, and then that's times y. So let's distribute that. I'm going to say area equals, this will be 50y minus y squared. Alright, and then there's my equation for area in one variable. So to find the largest possible area, we're going to be doing things just like we did in the previous critical point videos, taking the derivative, set it equal to 0. So that means that this is going to be dA over dy. The derivative of 50y is going to be 50, and the derivative of y squared is going to be 2y. And just like with the critical point problems, our derivative is set equal to 0 because I'm trying to find the maximum possible area. So from here, we're going to just solve for y. We'll add 2y to both sides. 2y plus 2y. That's going to give me 50 equals 2y. Dividing both sides by 2, I'm going to get 25 equals y. Alright, so 25 equals y. So that's the first part up here. I know that this y is going to be equal to 25. So I can use that information to find out what x is going to be. Looking at my two equations over here, my area equals xy equation right here isn't going to be helpful in me solving because I don't know what the max area is going to be. So I would have two unknowns, the a and the x. But looking at this equation, I can plug in 25 for my y and then solve for my x. So I'm going to have 100 equals 2x plus 2 times, I know what y is 25, so we'll plug in 25. Alright, so that's going to be 100 equals 2x plus 50. Bring the 50 to the other side, minus 50, minus 50. That's 50 equals 2x. Then divide both sides by 2 to get x by itself. So it looks like x will also be 25. All right, and that's the end of the problem. I now know that my biggest area in this garden will be achieved when my x is 25 and my y is 25.